Hello, my name is Gregory Osborne, video game audio composer and implementer, and today we're going to talk about how to get directional gestures from your controller to interact with your Unity scene. Specifically, when your hand reaches a trigger velocity, I want to send out an event that contains the direction vector of that motion, while also checking with a Raycast to see if I've hit an object that I might be gesturing to. For this tutorial, I'll be using Oculus integration and I'll be building onto my Quest. First, you'll need to import the Oculus integration package into your project for free from the Assets store. Once you've finished, you'll need to find the camera rig prefab by going into your project window, going into your Assets folder, then Oculus, VR, and finally the prefab folder, and drag the OVR camera rig into your scene. For this experience, we're going to want to know where our controllers are, so I'm going to create a couple of cubes for our right and left controllers, and I'll drag them under the left and right hand anchors in the tracking space in that prefab. I'll also create a plane and color it blue, just so we have some kind of grounding in the scene. We'll start with the event call that sends out the velocity vector information. I covered events in a previous tutorial, so feel free to check that out if you need further explanation on how events can be used in Unity. On a new object in the scene I'll call vector event call, we're going to create a new script called hand tracking, which will use Oculus's tracking data to send out events when a controller reaches a trigger velocity. In the script, we'll declare a public float that is the controller speed at which our event is called. We'll declare two events, one for each controller, by typing in public static event system.action and then in the carets vector3, and we'll name it the first one LH trigger and the second one RH trigger. We're sending a vector3 as part of this event because I want objects in the scene to be able to use the velocity vector of the controller as an input. We're going to create a method to check the speed of these controllers. We'll be getting this controller data from OVR input, which will only work if there's an OVR manager somewhere in the scene. Thankfully, the OVR camera rig prefab we dragged into our scene already comes with one. I'm going to call this method checkSpeed, and I'm going to have it receive an OVR input.controller so that we can run this method twice per frame, once for each controller. Back in the update function, we'll call checkSpeed once sending the left hand by typing OVR input.controller.ltouch in the parentheses, and then once sending the right hand. Back in the checkSpeed method, we'll declare a float called velocity speed and a vector3 called velocity vector, and give it the value of the controller speed by calling the function OVR input.getLocalController velocity in parentheses controller, which will return a vector3. Then we'll assign the speed of the controller by finding the magnitude of that velocity vector. Finally, we'll check to see if the speed is greater than our trigger speed float we set in the editor, and if so, we'll call a new function which will invoke our event. We'll call this new event calling method speedCheckPassed, which will accept the controller type, but also a vector3 for the velocity vector. We'll go back into checkSpeed to add these variables to the function call. We'll check which controller is calling this method so that we can then invoke the appropriate event. I'm creating this new method to call this event so that we can modularize our functions and keep the logic of whether we actually want to call that event separate, even if the speed requirement has been satisfied. Let's save and go back into the scene. In the editor, I'm going to put in a value for the trigger speed I've already tested out. I want to create a cube that moves in the direction of the velocity vector every time the speed event is called. Let's create a script I'll call vectorReceiverCube. In this script, we'll create a method called adjustPosition that adjusts the cube's position by a passed vector3. Because of previous experience, I'm going to divide the adjustment vector by 15 so that this cube doesn't go flying all across the scene. Then, in the start function, we'll have the script listen to both handtracking.lh and RH events and call this adjust position when it receives those events. Save this script, and then let's try out our scene. If you're like me and you're trying to build onto an Oculus Quest, I highly recommend this article, which is linked in the description, to help you set up your Unity project to be able to build to the Quest, which is not a simple task. If everything worked out properly, what should happen is that whenever my controllers are past a certain speed, this cube should move in those directions. Notice how currently the cube essentially duplicates the summed motions of our controllers when they're past a certain speed. Just for kicks, let's make it so that there's a reset time for the event being called so that the cube isn't moving so constantly. Go back into the hand tracking script and declare a float reset time, then a couple of booleans that determine whether the reset time is active. We'll create a couple of coroutines for each hand that turn on the bool, wait for the reset time amount of seconds, and then turn off the bool. Finally, in the speed check past method, we'll make it so that the events will only call if their respective reset timers aren't active, and then when they're called, they start their respective coroutines. When we save, go back into the scene and change the reset timer value to maybe half a second, and build. Now, we find that the cube only moves in spurts. You can use this for things like having the player direct wind with their hands, or even giving directions to a group of AI to help them navigate some kind of maze. But what if you want to have your player gesture towards things that are out of their reach? Let's say you don't want them to have to point, but rather just gesture vaguely in one direction or the other to select an option. One way you can do this is to have a Raycast come out of your controller's velocity vector and see if it hits anything gesturally interactable. Let's make an invisible prison around the player made of 6 rectangles that will only light up when the player gestures at them. For simplicity's sake, we'll keep this in the same script as the hand trigger. In future tutorials, we'll go over more complex interactions using this Raycast system. First, I'll create the 5-paned box around the player. I'll turn off all of the mesh renders and then create a new tag for them called prison. I'm going to make it so that when I gesture at the walls of the prison, they'll turn on briefly and then turn themselves off. Back in the hand trigger script, I'll create a new method called reveal walls that checks via Raycast if I've hit a wall and then runs a coroutine with that wall's mesh render. In order to call a Raycast, first you'll need to define a ray along which to cast this Raycast, as well as a variable of the type Raycast hit in order to store information about what it is you've hit. So first, declare a Raycast hit called hit. In order to define the new ray along which we'll test if we've hit something, we're going to need the position of the controller as well as the velocity vector to define the direction. So we'll make sure that reveals walls method accepts the controller type and the velocity vector. We'll declare a ray within the method and define it as a new ray that starts at the position of the controller, which we'll find at ovrinput.getLocalControllerPosition, in parentheses controller, and then extends outwards in the direction of the velocity vector. We'll create an if statement that checks if we've hit something at all via physics.raycast, in parentheses, the name of the ray, comma, out hit, meaning anything we hit will be stored in the Raycast hit variable hit, then a max distance of whatever float. I'll put 10f. Then in the same if statement, we can check if the thing that we hit has a tag of prison by typing hit.transform.gameObject.compareTag in parentheses the string name of the tag prison, because our Raycast hit variable holds all of that information about whatever it hits. In the if statement, we'll then start a coroutine that takes the game object, finds its mesh render, and enables it, then waits for the reset time of seconds before disabling it again. Finally, make sure that in the speed check past method, we're calling the reveals walls script at the same time as we're invoking the trigger speed event. Save this, go back to the scene, and run it again. You should see the walls show up when you gesture to them, even though they're out of your reach. This is an alternate way to select objects from pointing and clicking, and can be useful if you want to avoid using buttons on your controller, but still want to be able to keep some controls out of direct reach by the player. The next tutorial will cover how you can assign functions on these walls to perform different actions in the scene specific to which wall you chose, rather than having them all do the same thing as directed by the controller itself. In other words, have the walls use their Raycasted selection as a kind of scene-wide event. Thank you for watching, and I hope This has been helpful to those looking to use spatialized gestures in their experience.